Good morning.
Good morning, ma'am.
Okay, so how was your exam? How was your midterm? So before midterm, was supposed to we were supposed to have a unit test. Okay, so but we couldn't have it. So this week on Thursday we will have our first unit test, and that will be totally on SQL. Okay, it will be a unit test of 10 marks, and it will be totally on SQL. You just prepare yourself for only that particular topic SQL.
मैम सब्जेक्टिव और ऑब्जेक्टिव
Not objective. You have to write queries.
ओके मैम
So Thursday, this coming Thursday, I think it is 24th March. Yeah, 24th March. Unit test, first unit test 24th March, and topic will be on SQL SQL queries. So you have to write queries on SQL. Okay, so and
मैम
yeah, and happy. Yeah, hello.
can you please send us some questions on SQL so that we can practice?
Questions on SQL. Did you means I think I did give you some assignment on it.
Yes, ma'am.
No.
But the solution for the assignment,
Uh, Even you can find it in the web also, and if you want, I can search for it and then I can give you that. But I think many queries and many things related to SQL are there in the web. If you search for it, then you can find a lot of queries.
okay.
That's why I told you to practice on it. Means practicing, you need to search for, means you need to do some searching on the web, isn't it? You just can't practice only with the query that we have done in our class.
Yes, ma'am.
That's why before midterm I give you the assignment so that you can see the different ways of writing queries. You can check yourself how to write, means your ability to write the to solve the queries that is given to you.
Okay, ma'am.
Okay, so and yeah, one thing, uh, uh, okay, this week I did. Okay, let's start our class. If you have anything to say about the midterm, then you can tell me now before starting the class. Okay, then let's start. So this relational algebra, this is a topic that we are going to start from today. So this relational algebra, we were supposed to learn about it before SQL. Okay, because this is the core for your SQL. Because of this relational algebra, the SQL comes. So, but we have to start our lab classes also. That is why I started SQL before this relational algebra. Okay, so this is a formal language. Relational algebra is a formal language for the relational models that we know. So it is only for retrieving information from the relational model. So that means by using this relational algebra, we are going to write queries. Okay, So we are going to write queries, and this queries that is written by using relational algebra operators are known as relational algebra expressions. It is just like the mathematical expression. You have to write an expression using whatever operators we have in our relational algebra in order to solve of the queries that is given to you. Okay, in order to retrieve the information and that you need to retrieve. So the expression that we are going to write using relational algebra is known as relational algebra expressions. And as it is an expression, we are going to have operators and operands on it in this expression. Okay. Now, operators are going to be the relational algebra operators that we are going to learn after this. And these operands are going to be relational models. Okay, they are going to be relational models. That means the relational models are going to be operands, and the operators are going to act on this relational model, that is the operands, and then we will get a result, and this result is going to be the output, means the solution for the query that is given to you. Okay, and again this output is going to be the result is going to be a relational model. So you can see here relational model will be given as an operand, and an operator will act on it, and after that at the output is going to be another relational model. Okay, so let us see the operators one by one. The operators, we have set operators that we know from our set, that we can use in relational algebra also, like union, intersection, set difference, Cartesian product, division. We have these operators. Okay, and other operators, other relational algebra operators are select, project, join, and then renaming operators. There might be some other operators also that is available in relational algebra, but these are some few common, means the important operators that we are going to see here in our class. Okay, so we'll see these operators one by one. Again, these operators, all these operators that can be, they can be categorized as unary and binary operators. So unary operators, this is very simple thing. Unary operators are the operators which will act on a single operand, isn't it? And binary operators are operators which are going to act on two operands. Okay, so some of the unary operators are this select is also a unary operator, project unary operator, and then renaming operator is also a unary operator. And other operators like, other remaining operators are all binary operators. Union, binary operator, intersection, binary operator, set difference, Cartesian product, division, join, they are all this one, binary operators. Okay, so this is just a category of the operators. Let us see the operators one by one. The first is select. So this select is totally different with the select that we have in our this one SQL. Okay, you just forget about SQL right now. So this select, what is this select operator? I'll tell you. Select operation is used to select a subset of tuples. Okay, select, we are going to select tuples from a relation that satisfies a selection condition. So what it is going to have is this select operations. When we perform a select operations, what it is going to do is the operand is going to be a relation, isn't it? So from this relation, the operand relation, we are going to select some tuples. Okay, and this sum tuples, we are going to select it by using a condition, selection condition. So those tuples which satisfy the selection condition will be selected, okay, from the relation that is given as an operand. So the way of writing this expression is, means the symbol for select is sigma. Okay, symbol is going to be sigma. And the way of writing the expression will be, we'll have sigma, and after that here as a subscript, means here we'll have to write the selection condition. We'll write the selection condition, and after that we'll provide the operand, that is the relation, input relation inside the parenthesis. Okay, we'll provide it inside the parenthesis. And the output itself means after selecting, we will get a relation. Okay, this I have already tell you here that and we will have a relational model, and after the relational algebra operations is done here, the result is going to be another relational model. Okay, so the overall result by selecting by means after performing this expression is going to be another relational model. Okay, the number of attributes of the resultant relation is same as R. So this is a point you need to remember. Number of attributes that we are going to have in that resultant relation will be same as the attribute we have in R. Okay. And another point is select operation is commutative. That means we can have many selects. So inside means select inside select. Now you can say this one, nested selects. Okay, so this is the select statement. It will return a relation, isn't it? And we can have another outer select statement which will act on this resultant relation. Okay, so like that we can have nested selects, and selects is commutative means what it means is the selection that we have done here in the outer select, we can replace, means we can interchange these two selections. Okay, means we can apply, means the result for this will be same as the result we got from this. Okay, so selection that we applied here is applied here. Okay, the selection that is applied here inside this parenthesis is applied outside the parenthesis. They will give the same result. So that is why select operation is commutative. Example is given here. Select from employee, the selection condition is D number equal to 4. So this select, I already told you, this is to select tuples from the operand, isn't it? So the operand is employee. So from the employee table, what it is going to have is it will select the tuples, those tuples who is having DNO value equal to 4. That means who satisfied this condition that is provided here. Okay. So this is just for selecting tuples. Remember this. This is not same as the select that we use in our SQL. Now we can provide many selection condition at one time by using the logical connectivities like and or. Okay, so like this, if we have to provide many selection conditions, then we can join it by using and then or. Okay, so here what it is happening is we are going to select tuples of employees whose DNO value is 4 and salary is greater than 25,000, or whose DNO value is 5 and salary is greater than 30,000. Okay, so we can provide conditions like this also. So any doubt till here? This is a very simple thing. If you understand the SQL, then it is very simple. It is same as the where clause that we use in the SQL. We are just applying some condition, and according to this condition, the tuples will be selected. Okay. Now project.
Ma'am,
So
I have a
select.
question.
Yes.
Ma'am, regarding that, the Sigma select,
Yes.
it will not give us any output, right? It will not show us on the screen. It will just be uh chosen.
Yeah. I will tell you one thing. This is just there in a theory. Means this is just an you have your mathematical expressions, isn't it? Just like that, this is also an expression. You can't just mean there is no such software where we can write relational algebra expressions and we can execute relational algebra expressions.
Okay.
Okay, this remains as a theory, and from here we have developed our SQL, which we can use for execution. Okay, so just this is just in theory. You need to learn it just like the mathematics. You means in the mathematics everything is done in the in the pen and paper. You have to do it in pen and paper, isn't it? Like that here also relational algebra expressions, whatever we are writing, the input output and all of these relations, you have to just keep it in your brain, or you can note it in a paper. The output will be there for sure. I have already told you input is there and output is there. Input is going to be a relational model, means input is going to be a relational table, or you can say relation, and then the output is going to be a relation. That means you can't say there is not going to be any output. There will be an output, but the only thing is the output you have to means according to the application that is applying here, the output is going to be there. Okay, you just need to know the rules. Okay,
Okay, ma'am.
you can't write this relational, you can't execute this relational algebra expressions in a software. There is no such software available. Okay, so then let us continue. Next is project. So project means select is used to select tuples, isn't it? Project is used to select columns, or you can say attributes from the relation. So if we want only some few columns to be selected, then we have to use the project operator. And project operator, the symbol for project operator is pi. Okay, used to select columns from a relation. And the way we have to write this expression is this way. Pi, we have to provide the list of attributes here that we want to retrieve, and the operand will be given here inside the parenthesis. Okay. Order attributes same as mentioned in the attribute list, means in the resultant relation. In the resultant relation, we are going to have some attributes, isn't it? So the order of that attributes that we have in our resultant relation will be same as the order that we provided here. Okay, it does not depend on the order of attributes that is here in our R. So for example, in R, we are having attributes A, B, C, D. And that is also in that order, that is A, B, C, D. And if we provide pi C, D here, some D, A here. We provide D first, and after that we have A. Then in the resultant relation, the order will be same as the order that we provided here in the attribute list. D will come first, and after that A, we will have A in the right hand side of D. Okay. Duplicates will be eliminated. So duplicates is going to be the duplicate tuples. If we have any duplicate tuples, then it will be eliminated from the resultant relation. That means number of tuples of output is going to be less than or equal to number of tuples of the input. Okay, so in output and input is going to be the input relation and output relation, the operands and the resultant relation. Okay. And here you can see again we can have nested project operations. And here this nested project, this doesn't, I will tell you, this doesn't make any sense. That means instead of this, we can just apply only one single project like this. Why? Because whatever list we are providing here is going to be, whatever list we are going to provide here is going to be the subset of this list that we are providing here. And again, this is going to be the subset of the attribute we have in R. Isn't it? That means we do not need to apply this project if we are going to apply this. Okay, so that means this is same as this. The result of the pi, the project expression, the relational algebra expression that we have in this left hand side is same as the result that we are going to get from this expression in the right hand side. Okay, even here the things is mentioned here because list 1 is a subset of list 2. This is why, because list 1 is a subset of list 2. An example is provided here: pi, first name, last name, salary. So from the employee table, we are going to retrieve only the attributes first name, last name, and salary. If there is any duplicate, then duplicate tuples, then it will be eliminated. Okay. If there is a employee who is having same first name and last name and having again the same salary value, then they will be, those things will be eliminated and only a single tuples will be selected and will be placed there. Okay, so this is select and project. And now another thing I will tell you about select and project is we can use select and project in the together in a single expression also. Okay, so nesting of select and project. So in a single expression here, this is a single expression, we can see select and also we can see project. Okay, so we can apply both of them in a single expression. So first what will happen is from the employee table, the tuples who is having the NO value equal to 5 will be after that resultant table. From the resultant table, only the attribute first name is retrieved, is selected. That means what is happening here? We are retrieving the name, the first name of employees who is working in department number 5, isn't it? We are retrieving the name of employees who is working in department number 5. So you have to write the relational algebra expression like this. If a query is given to you, then you have to solve that query by writing an expression like this. Okay, or this is a single expression, isn't it? This is a single expression. Or in another way, you can solve it in different expressions also, like this. Here you can see this is same as, I will write an or here. Yeah, this expression and the result of this expression is same. Okay, so what is happening here, I will tell you. It is divided into two expressions. So in the first expressions, we are selecting the tuples who is having DNO value equal to 5. That means we are selecting the employees who is working in department number 5. Okay, and we are putting the values in this particular variable, relation. This is going to be a variable which is going to hold a relation, the value of a relation. Okay, so we have a relation here. Again, from this resultant relation here, you can see this resultant relation, we are putting it as a operand, and from here we are projecting, or you can say selecting, or you can say retrieving only the first term, and we will place it in a result. So whatever we have in this result and whatever we got from this relational algebra expression, they are going to be same. You can either write in a single expression or you can write in multiple expressions in order to solve a query. Okay. Another example is given here. This is example number 2. So here we have projected the first name, last name, and salary first. After that, from this resultant relation, we are selecting only those couples whose salary value is greater than 30,000. Okay. So what is going to be the attribute for this whole expression? Means what is going to be the attributes that we are going to have in the relation, in the resultant relation for this expression? Anyone?
Ma'am, salary?
Other any other student? Not just salary. We will have all of these things. Remember, project is to retrieve the columns, means the attributes, and select is to retrieve the tuples who satisfied this particular selection condition. That means in this, after applying this project in the employee table, what we are going to have is we will have a table which will have three attributes: first name, last name, and salary. Okay, we will have three attributes. And from this resultant table, we are going to apply this selection again. It will be selecting the tuples whose salary value is greater than 30,000. And it will have, from the definition of select, from the first slide, means from the slides that we have for this select, we know that, where is it? We know that the number of attributes of the resultant relation is same as R. That means it will have the same attributes. Will have the same attributes, that is first name, last name, and salary. Same attribute of this particular relation, okay, not the employee relation. You get it? What I'm trying to say? The overall result will have three attributes, and those three attributes are F name, L name, and salary. And the tuples that we are going to have will have the salary value greater than 30,000. Do you get it now?
Yes, ma'am.
Ma'am, then in that case, would it be the same if we interchange the position of this project and select, as in, I think it will be the same.
Yeah, it will be same. It will be same. You can see this means the condition applying here, and whatever means selecting here means we can apply the condition first from the employee table. After that, we can select F name, L name, and salary. They are going to be, you are going to get a same result if you applied the select first and after that project. Even here also it will be same. If you apply the project first, after that if you apply the select, then the result will be same. But in some few expressions, they might not be same. Okay, you might come with such expressions which will not give you the same result. So we can see that later on. The next operator is renaming operator. So renaming is just like aliasing. Okay, so we are just giving some we are just giving some name, some new name. So in the relation R, if we want to rename this relation itself, then we can give the name here as S. This S is going to be the new name. You have to provide the new name here. And if you want to rename the attributes also, then you have to provide the new attribute names inside the parentheses one by one, separated by commas. Okay, so this is for renaming the name of the relation and also the name attributes that we have in the relation. Okay, this is row. Okay, the row, the symbol row. So the symbol row is used for representing renaming operator. And if you want to rename only the relation, if you want to change the name of the relation and we do not want to change the attributes, then you can use this. Just provided the new name here and the operand here inside the parentheses. And without renaming the relation, if you want to, rename all the attributes, then you have to provide the new attribute names here inside the parentheses. Okay, so renaming is, we can use renaming only when we are using some set operations like union. So if we are going to perform a union on two relations, then those two relations should have the same attribute names. Okay, so for those things we will use this renaming operator. Other than that, we do not need to use this renaming operator. Okay. Renaming operators is useful for only those things. Set operations, for set operations. Okay. Now join. Join is same as the join we know from SQL. Okay. So join means it will be represented by this particular symbol you can see here. This is used for representing symbol join, and we will have two operands, left operand and right operand. Left operand is represented by this R and right operand is represented by S. And if you can also provide join condition here, join condition as a subscript to the join operator. And again, it will give you a relation queue. Okay. Used to combine related tuples from two relations into single tuples. We already know this. There is some relation between S and R. That is why we are joining them, isn't it? So the related tuples are going to join with each other, and then it will be, means we will have that particular tuple, the combination of the tuple from R and S, which is related to each other in Q. Okay. So you can, means it is even written here also, you can read it. Q has one tuple for each combination of tuples, one from R and one from S, whenever the combination satisfies the join condition. Okay, so this is the same concept that we know from SQL, the same concept of join. So employee join dependent with the join condition SSN equal to ESSN. Okay. So we are going to get the details of employees along with the details of dependent who is depending on that employee in a single table after this operation, isn't it? So here again, join, that was, this is inner join. This particular join is an inner join. We also have outer joins, like left outer join, right outer join, full outer join. So this again same concept that we know from SQL. So left outer join will be represented by this symbol. You can see here, we will have the same symbol for join, but we are going to have two hyphen here. Okay, it means it is left join. And for right join, in the right hand side, this hyphen will be there. Some extra symbols, extra marking is there in the right hand side. For full outer join, the mark will be in the left and also in the right. Okay, the concept is same. Left outer join combinations, possible combinations will be there, and other than that, all the remaining tuples of the left relation will also be there. Okay, for right outer join, all the possible combination will be there. Other than that, again, the remaining tuples of the right relation will also be there. Okay, and full outer join means that after getting all the possible combinations from the left relation and from the right relation, remaining relations of left and also the remaining relation of the right relation will also be there in the resultant relation. Okay, so outer join is used when we want to keep all the tuples in R, or all those in S, or all those in both relations in the result. So here you can see, if we want to keep all the tuples of R, then we will use left outer join. If we want to keep all the tuples of S, then we will use right outer join. Okay, If we want to keep all the tuples of the both relations, then we will use full outer join. Okay. Same again here also, we can group and we can also use aggregate functions. So grouping and aggregate functions will always come together. Okay. So grouping we have to do by using this script F. This is known as script F. This symbol, this particular symbol is known as script F. Okay, this is an F. So how we are going to group is we have to group, we have to apply, means whatever grouping attribute we have to apply it here in front of this script F. And if we are going to apply functions also, aggregate functions, then we have to write it here in the right hand side of the script F. Okay, and the operand we have to write it inside the parentheses like this. An example is given here. The input is an employee again. So the employee table, if we want to group it by using the department number value, that means we are going to group according to the department number. We are going to group the employees according to where they are working. Okay, then we will use the script F, and then we will provide the grouping attribute here, DNO. And if we want to retrieve some few things using the aggregate functions, then we will use the aggregate, we will write the aggregate functions here. Okay, so we are going to count the number of employees and we are going to find the average salary for that particular department. Okay, so what will be the result? The result, we will have the grouping in the resultant relation, we will have the grouping attribute, and then the other aggregate functions that we applied, count and average. So we'll have DNO, count SSN, and average salary. So in the employee table, you can see, where is the employee table? Okay. Any example employee table? Okay, here this is an employee table, isn't it? This is an employee table. So if we have to group it by using DNO, then we will be having two groups with DNO value 2 and DNO value 1. Okay, after that we are going to count the number of tuples, or you can say the number of SSN, unique SSN. That means for or 2 we have 2 unique SSN, isn't it? And for DNO equal to 1 we have 3 unique SSN. So for DNO 2 we will have the count SSN value 2, and for DNO 1 we will have the count SSN value 3. The other thing we are going to retrieve is average salary. So this for DNO 2 we are going to find the average salary, and for DNO 1 we are going to find the average salary. After that, these three things will be retrieved: DNO, count SSN, and average salary. Okay, like this. We'll have DNO, and then we have count SSN, and then average salary. So this means this is just, we are just taking this one conceptual relation. In the conceptual relation means in a relation in that particular conceptual employee table, we are going to have 3 department number values, 1, 2, and 3. And for 1, there are 456 employees are working in there. Okay. In department number 2, 23 employees are working. In department number 3, 78 employees are working. And the average salary, this doesn't make any sense. I will just give some more value. The average salary for department number 1 is 70,000. The average salary of department number 2 is 34,500. And average salary of department number 3 is 6,70,000. Okay, like that. So just you are just means this. I'm just showing you how the resultant relation will look like. Okay. Now union of two relations. This is again same concept of set operations that we know from our mathematics. R union S will give a Q. They are all relations. Okay, R is also a relation, S is also a relation, Q is also a relation. So we are operating by using the union operation on R and S, and the result is Q. So R, there is example is given here. And one more thing here, R should have the same number of attributes as S. R and S should have same number of attributes, and the name of the attributes should also be same if we are going to apply union between these two. Okay, so R is having ABC, and again you can see S is also having ABC. We are applying union to these two, and we will have the union of the tuples. We will have the union of these tuples and these tuples, removing the duplicate tuples. So here you can see this, the value, this tuple and this tuple is same. Then the last tuple of R and the first tuple of S is same. So from this two, we are going to have, for this two, we are going to have only a single one. Means we are just removing the duplicates, the redundant values. Okay. So the result will, we are going to get only 3 tuples after removing the duplicate one. This is union intersection. So again, this is same as the set operator. We have set intersection. So R intersection S Q. So whatever we have in R, from all the tuples we have in R and from all the tuples we have in S, we are going to selecting only those tuples which is in R and also in S, isn't it? That is an intersection. That is the definition of intersection, isn't it? So we can see that this tuple and this tuple means they are same. So if we perform intersection on this R and S, then in the resultant table we are going to have only this one. Okay. Set difference. So means if we perform R minus S, then we will have only those tuples in R which is not in S. Okay, means here in R we have 2 tuples. We will select those tuples which is not there in S. Okay, so 1, 2, 3 is not there in S, so we'll select 1, 2, 3. 5, 6, 7 is there in S, isn't it? So R minus S, we can't put this 5, 6, 4 here in the resultant table Q. Okay, so this is R, this is S, and this is Q. So this is set difference. Cartesian product. Cartesian product again, this is same as the Cartesian product we know from SQL and also from set. R Cartesian product S Q. So all the possible combinations of tuples from R and tuples from S will be there in Q. Okay, so here we have 2 tuples and here in S we have 2 tuples. So we are going to have 2 into 2 equals to 4 tuples because this is Cartesian product. All the possible combinations we have to do it. We have to combine tuples, isn't it? So we'll get 4 tuples like this. Okay. Any doubt? Any doubt? These are just simple concepts, basic concepts on relational algebra. They are all simple, isn't it? If you have any doubt, then you can tell me. Okay, so the last operator, this division operator. Division operator, this is somewhat complicated, you see here. So we are going to have R and S and we will get Q. So in Q, which attribute we are going to have in Q? So you can see this. If R equal to ABC, R equal to ABC means this is the set of attributes. This is not, this R, small letter R is not the name of that relation. Okay, the small letter R is the set where we are having the set of attributes of R, relation R. And S, small letter S, is also a set which is having in the attribute sets of the relation F. Okay, so if R is equal to ABC and S equal to B, then S should be a subset of R. If we are going to perform R divides, means if we are going to perform this division operation on R and S, then this S should be a subset of R. Okay, you can see here B is a subset of ABC, isn't it? Because B, we also have B here in R. So this is something that should be satisfied if we are going to perform the division operation on two relations. Okay, you can, I will read it again. If R equal to ABC, set of attributes of R, and S is a set of attributes of S, then S should be a subset of R. Okay, and Q will have R minus S attributes. R minus S attribute. That means it will have A and C. B will not be there. It will have A and C as an attribute, as its attribute. Okay. And what tuples we are going to get here in Q? Q has those tuples from R which are associated to every tuples of S. I will read it again. Q has those tuples from relation R which are associated to every tuples of S. So here in S we have A and B, isn't it? A and B. So we are going to find for those AC value, in R which is associated with both A and B. Okay, so I will just write these things here. So the combination of A and C, the unique combinations of A and C we have from this relation R are P1, one is P and 1. It should be small letter P and 1. And other combinations is Q and 2, Q, 2. And we have P, again P1 is repeated here, so we do not need to write it. We are just writing the unique combinations, okay? And Q and 2 we already have here, and the last one is Q3. So Q3. Okay, so we have these three possible unique combinations of A and C, the attributes A and C. Okay, so we have P1, Q2, Q3. So which combination we are going to have here? Okay, which combination we are going to have here as a tuple in Q? So that depends on the value of B, that is A and B. So from the definition of the division, it should be associated to all the tuples of this A, S, isn't it? Means it should be associated, this particular P1 should be associated with A and also with B and R. And Q2 would also be associated. If it wants to be here in Q, then it should be associated to both of this. Okay, now let us see. In R, P1 is associated, we can find from the first tuple, it is associated with A. And let me see whether it is associated with B or not. Yeah, it is again associated with B here in the relation R. Means it is associated with both the value of F. Means all the tuples that we have in F. Okay, so if it is associated with all the tuples of S, then we have to be, means that particular combination of A and C will it have to be there in the Q, resultant relation Q. So we have P and 1 here. Now let us check for the next one, Q2. Q2, you can see Q2 is associated with A, but we can't find Q2 associated with B. Okay, that means we can't put Q2 here. Now let us see the last one, Q3. Q3, 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 Q3. Q3 is associated with B, but it is not associated, means we can't find any tuples where Q3 is associated with A in the relation R. So that means we can't put Q3 here in as a resultant tuple here in Q. Okay, so the resultant tuple Q will only have the one single tuple P1. Okay, any doubt? Some few things you need to remember about this division operation is the set S should be a subset of R, means whatever attribute we have in S should be a subset of the attributes we have in R. Okay, and another thing is Q will have R minus S attributes. Okay, Q will have R minus S attributes. And the last point is Q has those tuples from a relation R which are associated to every tuples of S. And in R, you can have another two words here in relation R. Means the association should be there in this tuples in your R, relation R. Okay, so this is a little bit complicated, but if you understand whatever I have provided here, the rules for a division operation, then it is you will be able to understand it. Any doubt? Any doubt here in the division operation between two relations? Okay. Okay, then we'll continue this in the next class. So these are the operators that we have. So we'll see this, we'll see the queries in the next class. And for your attendance, you just type in your enrollment number in the enrollment number with your name in the chat box.
Ma'am,
Yes.
regarding tomorrow's class, will it be at 10 again, or will it be the usual 1 o'clock?